Shravana and welcome back to Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the previous videos, we have seen how to what is linked list, how to work on the linked list, what are the methods we can perform on the linked list. So, in the same data structures and algorithm series, from today we will start working on doubly linked list. So, a doubly linked list is a type of linked list in which each node contains three components. In the earlier videos, like in the singly linked list, we have seen only two components. One is the data and another one is the pointer to the next node. So, now how this doubly linked list look like? So now I am just highlighting the doubly linked list. So here if you can see here, it has three components. The data means what is what is the node value, that is called as data, and the pointer to the next node and also the pointer to the previous node. Why is it? Because this doubly linked list allows traversal of the list in both forward and backward directions. That's why this is called as doubly linked list. Whereas in the singly linked list, whatever I am highlighting now, we have seen in the previous videos as singly linked list, correct? This singly linked list contains the nodes with two components. One is the data, means whatever value is present in the nodes. Node value is nothing but the data, and the pointer to the next node, because this allows traversal only in forward direction. But whereas doubly linked list will allow us to traversal of the list in both forward and backward directions. Okay. Now we will see what are the other differences between the doubly linked list and singly linked list. So first one, as we can notice here, we have the pointer to the next node in the singly linked list. In the doubly linked list, we have the pointers from previous node to the next node and current node to the previous node. We have two pointers present in the doubly linked list, correct? And when you take the traversal also, in the singly linked list, we have to traverse from left to right, I mean within one direction. We cannot say one left to right and all, because it's based on the memory. So, but in one direction it will go, correct? In only the forward direction. But here in the doubly linked list, we can go in the forward direction and also in the backward direction. Okay. And when you come to this singly linked list, it requires less memory because it has to store only one pointer, correct? Only like this one is stored in somewhere, two is stored in somewhere, and only one pointer we have to have the place memory for storing that pointer, correct? So that's why singly linked list takes less memory for each node. But whereas this doubly linked list, it takes more memory because it has two different pointers to be stored. And coming to the singly linked list, inserting and deleting node requires updating only one pointer, correct? When we say we have a single pointer here, in any case, even in any kind of operation you take, insert or delete or whatever it is, only one pointer we used to assign it back, whether head, tail, and then the next pointer to none, like that. But whereas here we have to make sure that we are updating both the pointers, correct? So it takes an extra step to complete this doubly linked list. And coming to the complexity, because this is a single direction, this is a bit simpler, which is like the singly linked list is a bit simpler than the doubly linked list. Okay. I mean, we will see the use cases, then you will understand why we have these two, correct? So we have seen more like advantages using the singly linked list because of this simple structure, if you say, correct? Because it doesn't have anything, it has only forward traversal. Because of that, it makes it simpler. But the real-time scenarios are not always simple. It deals with complex scenarios, correct? So for that we may need to traverse through forward and then backward, everything we have to do. So that's why, even though for understanding or for maybe learning purpose this is simple, but for the real time use cases this might be more apt for us. So we will see where usually we will use this doubly linked list. So if you see, if you have any web browser, take anything, internet, web, what is that, Chrome or Edge, or whenever you are surfing something, if you wanted to go back, correct, you are able to just click on the back, navigate to the back button and then go back. How is it possible? Because it has to store that previously accessed website. What is the previous page? Then only you will be able to go back, correct? So which means that it is able to store the history of the visited website. This allows us to navigate back and forth between the pages efficiently. So this is mostly understandable use case I can come up with for this. And even with the text editors, if you take, there's this undo, redo operations we are able to do, because it is able to keep hold of the previous change of what we made to the document. Even in this this paint option, if you see also, I am able to do the Control Z and then coming back. It's not just the Control Z, like we can go back to the previous version or previous change that we have done, right? So for such kind of things we can use this doubly linked list. And if you take some media players, usually some of the media players use this doubly linked list to manage the playlists, so that we can easily move to the next or previous song or video. And coming to the operating systems, if you take, right, because this is where we will be needing these which one to choose, correct, which kind of data structure to choose. So operating systems may use doubly linked list to manage and schedule tasks and processes, so that it will allow us in efficient addition, deletion or traversal of the tasks within in which operating system we are in. And also, like, I have seen like some locations or stores where we wanted to move for, I mean, wherever the routes are mainly considered, right, for forward and backward efficiently, in the like route management kind of navigation systems are there in the real time. So there also we use this doubly linked list. And there are some caching algorithms. So doubly linked lists are used in these caching algorithms, like the LRU, like least recently used cache, where items are stored in order to use them that need to be efficiently removed or re-added. So wherever you see, we have to hold the previous state of the event which can be used in the later point of time. So we should be having the current history and the previous history. These kind of places we can suggest usage of doubly linked list. Clear? Now this is what is a doubly linked list, and we have seen the differences between singly linked list and doubly linked list. Now coming to this series, right, as we have done in the previous series of linked list, in this doubly linked list also we will see what all the operations that we can perform in the doubly linked list. And from the next class we will see the coding, Python coding of implementing a doubly linked list class, and then how can we add the element, how can we delete the element, and also insertion, deletion, the same thing actually, and how can we travel to the forward traversal, backward traversal, and how can we do search, update, and how can we display the contents, how can we count the contents, how can we reverse the doubly linked list, everything we can check in the upcoming sessions. Hope this is useful to you, friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.